So how'd you do with these problems? Comme ci, comme ça? Maybe yes, maybe no. All right, well, let's work on them. And by the way, if you did get like number one, then fast forward to number two. But let me work on number one with those of you who want to see it. So this is a fraction, yes. And so I know the directions say to simplify, but what's the word we always use when we have an answer that's a fraction? We try to reduce it. So I'm hoping that there's something in the numerator that will cancel with the denominator. So let's find out. So first off, do you remember what I mentioned in my lecture video? What's the first thing you're going to figure out? How many terms there are. So let's go take a look. I have 4 times x cubed times this parenthesis minus. Well, that minus tells me that this was what the first term. Got it? To the left of it was one term. Now, after the parenthesis, after the minus sign, I have this parenthesis times this parenthesis. How many terms do we have? Only 2. Got it. Now, I want to see if there's anything in common between the two terms. Right off the bat, we notice the parentheses in common. So we have x to the third minus 1. Now, the first one has negative 2 of them. That's interesting. The second one has 2 of them. You're like, well, how do I know what power to take out? You always take out the smaller power. So which one's smaller, negative 2 or positive 2? Negative 2, so I'm taking out a negative 2. So that kind of took care of these parentheses. And in the first term, I still have a 4x to the third. In the second term, I have a 2x. So you can still take out a 2 and an x to the power of 1, because this one only has 1 to give. Okay, good. So now let's see what remains after we factor this out. So we're taking out 2, which will leave a 2, and x to the power of 1, which leaves x squared. We're taking out this parenthesis to the negative 2 power, so that parenthesis is not left in the first term because we took it out, minus. So we took out the 2x, that's not there, right? So now the question is like, wait, I'm taking x to the third minus 1, quantity squared, and I'm taking out negative 2 of them? Let me sidetrack you. Remember, when you factor, that's a division process. So you have x to the third minus 1 to the power of 2, and you're factoring out this parenthesis, which means you're dividing out x to the third minus 1 to the negative 2 power. Remember your rules of exponents. When the bases are the same and you are dividing, what do you get to do between the exponents? You get to subtract, which means I have my base, and I take the numerator's exponent and I subtract the denominator's exponent, which in this case will give me to the power of 4. So, to the right of the subtraction sign, I still have x cubed minus 1, and it's to the power of 4. Good? Okay. And the whole thing is over x to the third minus 1 to the power of 2. And you're like, well, do I get to cancel anything? Well, now take a look. Because what we wrote in pink was what was in common. And do you notice this parenthesis, this base is exactly the same as this one? So that's good, right? Gratefully, this is all multiplication, yes? So let me give you one more sidetrack. If you had, let's say, 3a to the negative 2, and you had an a to the positive 2, what would you do if you weren't allowed to write any negative exponents? Since this is multiplication, you would bring this a down to the denominator, wouldn't you? And the power would be positive after you moved it. So here's the original a squared. Now here is this a, but now it's going to be a positive 2. Isn't this the same scenario? So that means This 2x is still here. This bracket is still here. But now, in the denominator was our original denominator of x to the third minus 1 squared. And we are now moving this parenthesis down to the denominator because it had a negative exponent. But now that it's moved, the exponent goes positive. Are you with me? Okay. So, if we want, we can distribute this 2x back into the bracket just so we can get rid of the brackets. So what would this be? 4x cubed. You're like, why are we redistributing? The 2x didn't cancel with anything in the denominator. We always take everything out that's possible, factor everything out that's possible, and sometimes it'll cancel with the denominator and sometimes it won't. But in the final answer, since the directions say simplify, I don't want those brackets left. So 4x cubed minus, and now we have 2x times this lovely parenthesis. And in the denominator, we have x cubed minus 1, but now it's to the power of 4. And you're like, hey, can't we cancel? Remember, this denominator belongs to both terms in the numerator. It belongs to the 4x cubed, and it belongs to the term following the subtraction sign. Normally, we leave it like this. If your instructor wants you to split it into 2 separate fractions, ask them. But normally, this is how we leave it. Good? Okay. Problem number 2, heading your way. Stay tuned. So how'd you do with problem 2? Good? If so, fast forward to problem 3. But in the meantime, those of you who want to see problem 2, let's work on it. Okay, so first and foremost, we have a fraction. They want us to simplify, which means we're going to try to reduce this fraction, correct? But what was my first suggestion? Figuring out how many terms are in the numerator. So I have a parenthesis times a parenthesis and then subtraction. Well, that makes everything to the left of the subtraction 1 term. And then to the right of the subtraction, I have a parenthesis times another parenthesis. Looks like we have 2 terms again. Anything in common with these 2 terms? Yes, this parenthesis. So let's write that down. We have negative x squared plus 4x plus 1. And to the left of the minus is a power of 1. To the right, it's a power of 1. Great. I guess we're just taking out a power of 1. Works for me. Sometimes we get very fortunate in that respect. All right, so let's find out what's left. We have 12x to the third plus 2 minus, and then we have this negative 2x plus 4. Agreed? Okay. And then all over the denominator. Got it. Okay. Can I reduce? I certainly can. This, what we factored out, is going to cancel with one of these parentheses, which makes it now to the power of 3. Agreed? Okay, so let's see what's going on in the brackets. We have 12x cubed plus 2, and now I'm going to distribute this minus sign into these parentheses, right? Okay, so that becomes a positive 2x and then a minus 4 all over this denominator. And remember, these parentheses are now to what power? They're now to the power of 3. Got it. So, collect like terms. We'll have 12x cubed plus 2x. Looks like that's minus 2, agreed? All over this lovely denominator. And the question we need to ask ourselves is, are we done? Is there any more reducing I can do? What do you think? What did you do on your papers? Some of you said yes, because do you notice in the numerator? You can factor out a 2, can't you? And when you do that, you're left with 6x to the third plus x minus 1. And that's over this 8 times the parenthesis negative x squared plus 4x plus 1 to the power of 3. What can you do? The 2 and the 8 are going to cancel, which is going to result in 6x to the third plus x minus 1 all over 4 times the parentheses negative x squared plus 4x plus 1 to the power of 3. Sometimes not all the reducing is apparent until you get to the end and you're like, wait, there's still something else I can factor out. And gratefully, in this case, it did cancel with that 8 in the denominator. Good? Okay, problem number 3, heading your way. Okay, ready for problem 3? Let's do this. How many terms did you get? 2. Excellent. I see the subtraction sign. I see multiplication to the left of it and multiplication to the right of it. Wonderful. Now, you factored out what was in common, so talk to me. You could take out a 3, because I have a 9 and a 6 here, don't I? So I could factor out a 3. What else? You notice the parentheses are in common. So you said you're taking out a 2x minus 1 to what power? Good, 1/3, because 1/3 is smaller than 2/3. And that was it? Okay, let's see what's left. Let me get my brackets. So you took out a 3 from the 9, you factored it out, which leaves you a 3. 2x minus 1 to the 1/3, well, you took that out, so minus. You factored out a 3 from a 6, which leaves 2. We have 4 minus x, and then you took out 1/3, right? You factor out a 1/3. Remember, when you are dividing, you subtract the exponents, which tells me you have 2x minus 1 to the 1/3 power that remains. You're like, I don't like that. Well, that's kind of the way it's working. So we have to remember, we can't force it to look like we want it to, but, that's the way it rolls. Okay, now what? The 3's are going to drop. Excellent. Bye-bye. You're like, but I don't know what to do with this and the denominator. So let me sidetrack you a second. In our denominator, we have the cubed root of the quantity 2x minus 1 squared. So remember how to rewrite a radical into a rational exponent. My base is 2x minus 1. It has a power of 2, but a root of 3. So technically, I could rewrite this denominator as 2x minus 1 to the 2/3 power. Because now it makes it a little more obvious what I'm going to do. I'm going to cancel. I'm going to reduce these two bases. They're the same. So what do you do with the exponents? You subtract. And in this case, I'm going to do the denominator minus the numerator because I'm trying to cancel. And it's going to be left in the denominator. And yeah, this is going to become a 1/3, right? And this is going to cancel out completely. Does that make sense? Okay, so in the brackets, we have 3 minus. Now I'm going to distribute the 2 inside. 8 minus 2x, still being multiplied by this 2x minus 1 to the 1/3 power. And the whole thing is over 2x minus 1 to the 1/3 power. Is there anything else we can do? Some of you are like, I want to cancel these. I get it. But remember, this denominator is also the denominator of the 3. You could split it into two separate fractions if that's what your instructor wants, and then you would be able to cancel these guys. But for the time being, this is how it stays unless directed otherwise. Good? Okay. If you need to rewatch this one because the exponents were fractions, then rewatch it. In the meantime, problem number 4 is about heading your way. Okay, last problem. How'd you do? Tell me how you started. You decided there were 2 terms in the numerator. Got it. So let me look. Multiplication, multiplication, addition, and after addition, okay, good, I agree. 2 terms in the numerator. Then what? You decided what was in common, so talk to me. So right away you notice the parentheses. Okay, the parentheses are pretty hard to miss. So you notice there was a 7 minus 5x in common to what power? -3 or -4? And if you're uncertain, which one is smaller? The -4 is smaller, so you're taking out to the -4th power. Okay, so that kind of takes care of these guys in terms of what you can factor out. Now you have a 60x squared and an 8x left. Is there anything you can take out of there? Yeah, you can. You can take out a 2 because, or pardon me, a 4, because 4 is in common with a 60 and an 8, and an x to the power of 1, because x squared and x. Good. I'm agreeing with you on that. So let's see what remains. Where are my lovely brackets? So 60 divided by 4, 15. X squared divided by x, just an x. This parenthesis, what's the -4th power? And that's what you're taking out, so it's not there anymore, right? Plus. Now you have 8x divided by 4x. Well, that's just a 2. And now this one. So let me write it by itself over here so you can see it a little clearer. And you're dividing, because you're factoring out, 7 minus 5x to the -4. Remember, when you are dividing the same bases, what do you do with the exponents? You subtract. So 7 minus 5x, -3, subtract the denominator's exponent. Well, that makes it addition, which means that's just going to be to the power of 1. That's nice. I like that. Good? Okay. And now what do we have in the denominator? We have 4x, and in parentheses, 7 minus 5x to the power of 2. Okay. What's going to happen here? Yeah, these 4x's drop out, don't they? Bye. Then what? Ah, these bases are the same. That's true. This is to a negative power, and it's being multiplied. Does it belong in the numerator? You're right, it doesn't. It belongs in the denominator. So let me write the denominator first. So in the denominator is going to go 7 minus 5x. And is it going to stay a -4? Excellent. It turns to a +4 because you moved it. This 7 minus 5x is still in the denominator to the power of 2. Now, in the numerator, let's see what we have. We have 15x plus 2 times 7 minus 5x. Ready to simplify? More, I should say. So what do we have in the numerator? 15x plus 14 minus 10x. If you don't mind, I'm going to simplify this. That becomes 5x plus 14 over. Bases are the same. What are you going to do with these exponents? Good, you're going to add them. So 6. That's about all we can do, isn't it? Good? Does this make sense? Rewatch this one if you need to because the exponents were negative and you kind of have to be cautious because what we think is larger is smaller because it's further away from 0. Good? Okay, have fun with this stuff. Catch you on the flip side.